Welcome to this explainer. I am so incredibly pumped you're here today because we are going on a really fun journey together. We're taking a subject that is quite literally the universal benchmark for difficulty, rocket science, and we're going to completely demystify it. By tapping into some of the most phenomenal resources out there right now, we'll chart a clear path from learning basic forces in math all the way up to understanding real-time lunar missions. Trust me, by the end of our time together, you'll see exactly how you can go from an absolute beginner to an informed expert.
Whenever we face a tough problem in life, what's the first thing we say? Well, it's not rocket science, right? We've built up this whole idea that aerospace engineering is this giant insurmountable wall of knowledge reserved for, a few isolated geniuses in light coats. And yeah, sure, grasping all those concepts can be super intimidating. But what if I told you there's a curated roadmap specifically designed to tear down those walls? You really don't need to be intimidated if you know exactly where to look.
Okay, let's dive into this. Here is our step-by-step path for today. 1. Grasping rocket science basics. 2. Deep dives into aerospace. 3. Space flight for everyday people. And 4. The next lunar frontier. Starting right off with Section 1, Grasping rocket science basics.
Here's our roadmap for this explainer. If you want to nail down rocket fundamentals, the NASA Glenn Research Center is your starting line. For actual calculations, Rocket Mime is for sure your best bet. And to see modern rockets explained, we've got the Everyday Astronaut. Now, as you advance, you'll definitely want to bookmark the NASA Launch Services Program for Launch Systems and the Space Launch Report for their incredibly extensive rocket databases. But let's take a closer look at that first resource. What's wild here is how the NASA Glenn Research Center bridges the gap between your backyard and the launch pad. They intentionally compare things like toy stomp rockets, which, by the way, they hilariously point out are basically a special kind of artillery shell, and bottle rockets right alongside full-scale boosters. And why do they do that? Because it proves they use the exact same underlying physics. If you can understand how a bottle rocket flies, you literally already have the foundational knowledge for how a spacecraft escapes Earth's gravity.
The NASA Glenn site is specifically targeted at a high school to early college level, but honestly, it is totally accessible for anyone. They break down the fundamentals of forces, basic aerodynamics, thermodynamics, and gas dynamics. But what I love the most, it's not just some boring wall of text. They have these interactive Java applets like the Rocket Modeler 2 and the Rocket Thrust Simulator. You can actually design and fly rockets on your own computer. It's hands-on learning and it builds your confidence instantly. Now, for those of you who want to skip straight to the hardcore numbers, there's this amazing resource called the Rocket Mime Space Web. Hosted by Randy Culp, this site gets right down to business. It is a fantastic repository for essential rocket and telescope equations. It's really the perfect companion when you want to put the math behind those theories you just learned from NASA Glenn.
Which brings us to a really fascinating crossroads. We have our physics and we have our math equations. But, numbers on a piece of paper don't go to space. How do engineers take these foundational concepts and actually build these mind-boggling machines?
Let's explore that in Section 2, Deep Dives into Aerospace. The YouTube channel Real Engineering has this massive catalog of deep dive documentaries that perfectly illustrate the insane engineering behind aerospace history. They cover everything from how the space shuttle worked to the X-15, the Perseverance rover, and even the James Webb Space Telescope. When you watch these, you can actually see the aerodynamics and thermodynamics we just talked about being applied to solve real-world problems. It is just the ultimate showcase of human innovation in aerospace.
Moving right along to Section 3, Spaceflight for Everyday People. Man, I just love this quote from Tim Dodd, the creator behind the Everyday Astronaut. He says, "Rocket science can be extremely intimidating, but you don't need to be a rocket scientist to be excited." The crucial takeaway here is that you don't need an advanced degree to have a personal connection to space exploration. You just need curiosity. And Tim has built an entire platform dedicated to helping visual learners understand these complex concepts completely from scratch. The sheer volume of knowledge on the Everyday Astronaut platform is just staggering. I mean, he explores the intricacies of SpaceX's Raptor engine in videos that literally have millions of views. He breaks down the crazy complex physics of aerospikes versus bell nozzles. He even does these multi-part, hours-long tours of Starbase with Elon Musk, getting right up close and personal with the rocket factories. And when history happens, like Starship or Falcon Heavy launches, he provides incredible live streams. He uses detailed charts and 3D animations to ensure that even the most complicated systems, like Starship's lunar landing and refueling processes, are visually digestible for all of us.
And that leads us to our final section, the next lunar frontier. According to the latest updates straight from the NASA YouTube channel, we are living through a wildly active timeline of space history right now.
In the spring of 2026, we've got the highly anticipated news conferences and coverage for the Artemis II splashdown and return, where humans will have actually flown around the moon. Following that, momentum builds toward the monumental Artemis III mission scheduled for 2027. The engineering we've been learning about isn't just a thing of the past, it's actively making history as we speak.
Now, what's really fascinating about Artemis 3 in 2027 is that while this specific mission won't actually land on the moon, it's designed to practice docking the Orion spacecraft with 2 lunar landers in low Earth orbit. This brilliantly illustrates the sheer complexity of modern spaceflight. Because before we can safely bring astronauts to the lunar surface on future missions, we have to meticulously test these highly complex rendezvous capabilities right here in Earth's orbit. It's all about taking calculated incremental steps to return humanity to the moon, and this time to stay.
And behind all of this massive engineering are the actual humans putting their lives on the line. NASA just recently introduced the crew for this historic Artemis III mission. We have NASA astronauts Randy Bresnik, Frank Rubio, and Andre Douglas, joining European Space Agency astronaut Luca Parmitano. Putting faces to these missions really grounds the massive scale of rocket science, reminding us of the human courage that's driving all this exploration forward. Which brings us right back to our core theme today, perfectly summarized by the Everyday Astronaut's mission statement, bringing space down to Earth for everyday people. We started with the idea that rocket science is an intimidating wall, but through interactive math simulators from NASA Glenn, comprehensive equation databases, gorgeous engineering documentaries, and passionate deep dives, that wall becomes a staircase. The resources are out there and they are completely accessible to you.
So, I want to leave you with this question. Which part of the rocket science journey are you going to explore first? Are you going to dive into the aerodynamics of stomp rockets? Or are you going to boot up an hour-long documentary on the James Webb Space Telescope? The universe is waiting, and you now have the ultimate roadmap to understand it. Dive in, keep learning, and I'll see you in the next explainer.